Okay, so now consider RC circuit, and current I of t is flowing, and let's assume that the current I of t is equal to Im cosine of omega t. So total voltage will be equal to VR of t and Vc of t, okay, and VR of t is equal to R times I of t, which is equal to R Im cosine of omega t. And what about Vc of t is equal to 1 over c integral it d of t is equal to 1 over c integral Im cosine of omega t dt, which is equal to Im omega c, and it is sine of omega t. Okay, so this is Vc of t. So just adding the two here, we have Rim cosine of omega t and Im omega c sine of omega t. Okay, again recall the voltage, total voltage representation, that let's assume that it can be represented as cosine of omega t plus phi. Okay, so this can be represented as a cosine of omega t cosine of phi minus a sine of omega t sine of phi. Okay, so comparing these two equations, so let's say it is equation number 1 and it is equation number 2, exactly the same treatment as we did in the RL series circuit. So Rim is equal to a cosine of phi and Im omega c is equal to a sine of phi. And from these two equations, we can represent this as tangent phi is equal to 1 over omega c, because I will cancel with this. So cosine phi divided by cosine phi is equal to this thing. Phi is equal to tangent inverse 1 over omega RC. Okay. Similarly, taking square of these two terms, adding them, then we can have A is equal to standard marker. So we have R square plus 1 over omega c square into Im. So Im is just taken out of the square root, and cosine of phi is equal to R divided by R square 1 over omega c square root. Okay, so just if you look at this angle, and if R and omega c, if you just look at this behavior, of course the angle is a leading angle, but it is less than 90 degrees. Okay, so by changing the value of R with respect to C, we can simply either make the circuit more capacitive, or we can make the circuit more resistive just by changing the value of R. So if you just make this R very, very large, then of course this circuit will be more resistive. If you make the value of R very, very small, then this circuit will be more capacitive. Okay.